Welcome to Microchip Technical Support. This video covers the preliminary debugging techniques that you can use to determine whether an issue is software-related or hardware-related. Because the complexity of applications can vary, it is important to document the precise conditions under which the issue occurred, including the number of times you encountered the issue. You can apply the following isolation techniques with devices running simple firmware applications and even complex embedded operating systems. Sometimes the problem can be a simple connection issue, so we recommend starting with these hardware isolation techniques unless you know the issue is observed in software. The following are the techniques that you can employ to determine if an issue is hardware-related. First, you can verify hardware connections. Verifying hardware connections involves checking the external connections, such as cables and wires, board-to-board mating contacts, and printed circuit board, or PCB, traces. Check for loose connections and incorrect connector orientations, as well as jumper configurations. Ensure that accessories like cables match your desired requirements. Keep cables and wires as short as possible. Make sure the PCB traces are connected and are following the specifications listed in the official documents like datasheets and user guides. Follow the connection guidelines when using tools such as programmers, oscilloscopes, and logic analyzers to minimize any effect on the target device. Inspect for manufacturing-related issues like cold solder joints, damaged pins, and cut traces. Second, you can check the parts used. To isolate where the issue is coming from, you should check the part numbers of the devices used. Make sure that the part chosen in the development environment matches the physical device. Device documentation is normally available on our website. Using the datasheet, you can check if the electrical parameters are within specification. A Microchip device may exhibit unwarranted effects if any parameter is out of the specified limits. Be sure to check any related errata documents, which summarize silicon issues and the available workarounds. Third, you can simplify the setup. Another isolation technique is to simplify the setup, which is done by removing any unrelated connections and devices, as well as disabling the peripherals not related to the issue. For reference, the minimum required connection to power up a device is normally found in the related datasheet or user guide. Another simplification technique is to use on-chip peripherals instead of external peripherals. An example would be using the internal clock instead of an external clock. If the device seems unresponsive, an effective way to verify if the setup or device is working is by developing a simple application, such as toggling a general-purpose input-output pin, or GPIO pin, with a visual aid such as an LED, logic analyzer, or oscilloscope. The fourth technique is to replicate the issue using another setup. To verify if the behavior is related to the device in use, try a component swapping technique. This technique involves physically installing the suspected device to a board that you know works. It could be another prototype board or an evaluation board from Microchip. In this way, you will know whether the suspected physical device is the root cause or not. If you need to use a new prototype board instead, use only the minimum connections required. You can find available development tools and evaluation boards on our website. We strongly recommend having at least one development board on hand for this express purpose to get you back to development more quickly. Many times, the problems are caused by test equipment. Testing with another host computer or using another programmer can help isolate issues caused by such equipment. The fifth technique is to use debugging tools. There are several distinct types of tools you can use when troubleshooting. A digital multimeter, or DMM, is a great tool for checking continuity, DC voltages, currents, resistance, and sometimes even capacitance. However, a DMM is not always sufficient for finding the cause of an electrical problem. Additional tools may be required. If you're performing communication protocol analysis, you might need a logic analyzer, oscilloscope, or a protocol analyzer. These tools provide real-time visibility into the communication signals of your embedded system. With these tools, you can verify bus traffic, signal integrity, and data validity for communication protocols such as USB, I2C, SPI, CAN, and UART. Before performing any type of verification or protocol analysis, make sure your test equipment is properly calibrated and configured. By following the hardware isolation techniques, you can catch most of the hardware-related issues. If you still cannot catch the issue, it is prudent to perform the following software isolation techniques. There are several techniques you can use to determine if the issue is software related. The first technique is to change the development environment. To isolate software issues, test using different released versions of the utilized software. This includes integrated development environments or IDEs, device packages, compiler versions, drivers, and even operating systems. As fixes are made with each release, simply updating to the newest available versions and following any related migration guides can be all that is needed to fix an issue. Another way to verify a firmware issue is to utilize a simulator in place of the hardware setup. The second technique is to create a simple test code. You can create a simplified test code by removing all unrelated functions, drivers, and stacks to isolate software issues. Alternatively, moving to bare metal code can remove the possibility of issues in the stack abstraction layers. To effectively isolate software issues, try to disable software features and peripherals one at a time. If the simplified version of the software works, add functions back to the software one at a time until the issue reoccurs. The third technique is to cross-check your code against device specifications. If something in the code does not work, you should cross-check the code against pertinent reference documents like datasheets, reference manuals, and application notes. By doing so, you can ensure that you are manipulating the correct registers and performing required steps in the right order. If you are working with software libraries, they normally have documentation that explains the drivers and stacks in detail. The fourth technique is to test the code in known working hardware. Another way to isolate software issues is by running the code on a known working development setup. There are many available development boards and kits where you can test the custom code. We highly recommend getting an evaluation kit for testing purposes. The fifth technique is to check sample codes. Most devices have released example codes and demo projects that you can use as a reference to compare with the suspect code. Using such code comparison methods, you can identify key differences. You can find example codes in several locations such as mplab-discover.microchip.com, microchip.com/codeexamples, the Advanced Software Framework, or ASF, and the official Microchip GitHub pages. While performing the isolation strategies, it is important to record the verification steps taken. Examine the test results to find the possible source of the failure. At this stage, it can be helpful to enlist a colleague to get a fresh pair of eyes on your code. By using these methods, we hope you can now identify whether the issue is hardware or software related much more quickly so that you can get back to your development. Remember, technical support and information we share, including recommendations for device selections, are provided for your convenience. It is your responsibility to ensure that your selection of products and software meet your requirements when used within their operating specifications. Use of Microchip products and software is governed by the Microchip Terms and Conditions of Sale found at microchip.com/legal. Thanks for watching.